Again, thank you so much for joining this session. This is a platform that we empower each other, we learn from each other, we share knowledge, and try to become better engineers. We've been having this session since last year. We had IP RAN training session, multiple sessions discussing IP RAN technology. This year, we are having these sessions on different topics just to try and understand these networking principles as network engineers. This is our third session for this year. We had our first session by Eve discussing subnetting, and then the last 2 weeks we had a session by Motiva discussing OSPF. Today we are glad to have Marco taking us through BGP. We know that BGP is a protocol that you cannot miss as a network engineer. You need to understand it properly. You need to know how to configure it. You need to know the working principles, how to play around with different features so that you can fully utilize the power of BGP. So today we are happy to have Marco taking us through BGP basic principles. We know that BGP is very wide. We may not be able to cover everything in one session. That's why today we have Marco taking us through the basics of BGP. And Marco, we are very glad that you accepted the invite to take us through this session, and we are looking forward to learning from you. You can take it over and take us through the protocol of the internet. To you, Marco. Marco, you can take it over. We can't hear you. Anyone who is able to hear Marco?
Can't hear him.
Cannot hear him.
Okay.
Yeah, I can't.
Let's give him a minute. He should be able to start the session once he's ready to take over and do the presentation. Just a minute. He's having some issues with the microphone, but it should be okay. Marco, if you can test again. Let's give him some few minutes. As we wait for him to... Okay, I see you are muted, Marco. If you can unmute.
Hello?
Yes, now we
Sorry.
can hear you.
Okay, I thank you so much for this opportunity for me to present this important protocol. I was inside the the meeting before, but I cannot hear the meet, and now I am here. Thank you for your patience. So, Martin, can I start to talking about BGP?
Yes, we were actually waiting for you. We were just waiting for you to fix the microphone, and then
Okay.
so you can pick it up from there and take us through BGP.
Okay, let's go. We start about why you should learn BGP if you are not an ESP is the topic of tomorrow's session, today's session. I'm Marco Boschini from Italy. I am a Microtech certified trainer. I have all the certification about MicroTik, but my first goal is to explain network topics. Yes, I will use MicroTik because it's available, is easy to use for new technicians, but my first goal is about the standard of the networking. I found a training center in Italy, Boschini Training Center, and Corsi MicroTik is the name of the section of this training center about MicroTik certification. I have a case study to talk about today is optimizing gas station connectivity. Um, we are going to do some simple lab that explain the concept behind a real and very large environments with more of 300 remote clients connected via VPN with MikroTik device. This is the case study. I have some gas station remotely connected through VPN tunnel to one router core. And on the office of the manager, we have another router, and the manager need to reach the point of sale. And the point of sale need to reach a payment system through VPN tunnel. This is the concept of the connection and the concept of the manager. Okay. A backup system is required to ensure continuity of the service in the event of a central VPN server failure, and the design now become these two core router to permit availability of the service. And we will see, we can see that there are more tunnel VPN to configure, and if you are using a static routing, it can be difficult to create a lot of static route. The routing policies was applied by a static routing network and script inside the MikroTik router. That solution was not scalable, and the maintaining of that system was difficult. Knowing BGP, the Border Gateway Protocol, the way to solve this problem is clear. With BGP, the system is scalable by design, and the availability of service can be done by session BGP state and manipulated by filters. The agenda of today's session is Hello BGP, a simple example of BGP communication, the concept of autonomous systems, the external BGP, BGP session, BGP of the packets and attribute, BGP best path selection, the start of BGP best path selection, BGP filters, iBGP, internal BGP, and the next stop choice, i.e. BGP split horizon, BGP route reflector, and solution of the case study that we previously seen. How about BGP? In the past, every time I'd approached to learn BGP, it was always complicated because it starts from ISP scenario. And it's right, because BGP was designed to solve a complicated routing policy in the ISP environments. But people often think BGP is designed for ESP. Hey, I am not an ESP, I am a system integrator or a simple technician. BGP is overcomplicated for what I need, and I don't need BGP. Individuals do not learn well if they not see a reason for it, said to me Kaspas Krampis, my microtik trainer when I was in microtik to become a microtik instructor. And I noticed this sentence. Usually when individuals, students, start to study BGP, they don't have idea how about an ISP works, and this often makes BGP overcomplicated to understand. Today I want to talk about BGP with a real case study in a no ISP scenario. Let's start from the basic routing concept. I hope that you previously know that device inside the network communicate because they use the ISO with 7 layer. In the layer 1 we have the media, for example the cable, the Ethernet cable, and in the layer 2 we have the frame Ethernet, the destination MAC address, the source MAC address, and the payload. And inside the payload we have an IP packets that the layer 2 I use a layer 2 to communicate with the same segment network, my local network, and with the IP address, the layer 3, I can communicate with a network that is outside of my network. Okay, inter is outside of something. And a router is a device that permit to reach network outside my network. And a router forwards packets by looking at the destination IP address, this IP. If I have a router with two simple interface with an IP, for example, 192.168.20.1/24, the router know that all this network is connected to the Ethernet 2, for example. And if the router have the Ethernet 3 with the 192.168.13.1/24, the router know that the network 13 is reachable by the Ethernet 3. Inside the MikroTik router, if I print IP router, I can see, for example, dynamic active connected route on Ethernet 2 and dynamic active connector route on Ethernet 3, for example. The router forward packets because he know the destination where to put out the packets to reach the destination, and this information is stored inside the RIB routing information base. And when the router select inside the RIB, we can have more routing information. We can have the connected router that we previously see, and we can have the static route. I can route some static route to reach some destination. We can have BGP route that I received from a BGP process, and other, for example, OSPF or ISIS or a router needs to select the best path to reach the destination if he have more route, and this best path is moved to the forward information base, the real table that permit the router to forward routes. The FIB contain only the most efficient active routes required to forward packets. Okay. Let's start with a simple static routing lab. I have a router 1. In the router 1, I know the LAN 1, and I know the LAN 10.0.0.0/13, but inside the router 1, I don't know how to reach network 2, okay? And in the router 2, I have the network 2, I have the network 10.0.0.0/13, but router 2 don't know how to reach the network 1. I need to configure static route, for example, to fix this. In the router 1, I need to write the destination 192.168.2.0/24, and I need, from the point of view of router 1, I need to configure the device on the network, this network, that permit to me to reach the other network, the gateway or the next hop. Inside the LAN, I need to know the MAC address of this device. And if I set 10.0.0.2, I can do ARP protocol. I receive the MAC address of router 2, and I can use that MAC address to send to router 2 a frame method to router 2, and inside is contained an IP packet to reach PC2, for example. Okay. Usually, when I have a training session in class with people, I usually see that there is a difficult to understand this, and a lot of people tend to use inside router 1 10.0.0.1 as a gateway, but I need to know the other point, not my point. I already know my point, okay? I already know my IP. I need to know the other IP that permit me to reach the other network. This is the action. And with static routing, we add the routes here inside the RIB, okay? And in the router 1, I can use IP route, add destination address 192.168.2.0/24, and the gateway 10.0.0.2. And if I print the RIB, the route information base, IP route print, I can see my connected network and the active and static new route is active, and if there is the flag active inside the routing table, it means that the router are use this route to forward packet inside the field, okay? And in the router 2, I need to create the some configuration to reach back the network 1, and inside the router 2, IP route, add the destination address 192.168.1.0/24, this network, and from the point of view of router 2, I must use 10.0.0.1, this IP address, okay? And now the device, the two networks can reach each other. With BGP, we add the route inside the RIB, but in another fields, okay? We can have the same result, but dynamically and not in static mode, okay? With BGP, we can add the routes here. The static is here, the BGP is here, but the feed is the same for the point of view of the routing forwarding. Now, we are going to route our first configuration to get the same result as the previous static routing example. So I hear a microphone open. Okay, thank you.
Yes. Sorry to interrupt. There is a question on the chat, and the
Okay.
question is coming from Evans. He's asking about FIB stores the best routes or the best selected routes only. I think he wants to clarify which kind of routes are stored in the forwarding information base.
Fib store the best route or the best selector route only. The best route, it depends. If, for example, have a equal cost multipath, because I have two routes that point of the same network with the same cost, I can have multiple route inside the FIB. And in this case, we can have equal cost multipath, and inside the FIB I have a more route, and with an algorithm. Sorry, because I need to think in Italian and to translate in English. I can have an algorithm, is a round robin with an hashing. For example, I can hash the source IP and the destination IP. And if I have a result of this hashing, I can select the first route, for example. And if I select hashing different, I can use the second route. And the first route and the second route, I can have multiple route inside the FIB that points of the same network. For example, if I have equal cost multipath, is you can reach these, for example, if you are using two static routes that have the same destination address but with different gateway, and the same distance. In this case, this distance is 1, because with a static route, you must use minimum distance 1. Only the connector route can have distance 0, and distance 1 is the minimum when you are using the static route. Or for example, if you are using OSPF, you can reach the same destination with multiple path, and in this case you can have equal cost multipath. Okay. How long does they stay stored? Oh yeah, interesting topics. Today I will discuss about BGP, and I will not to go over deep dive, because with Martin we said that this is an introduction about BGP, and this is an advanced topic. But in this case, MikroTik, I can respond about MikroTik. MikroTik use Linux kernel, and MikroTik stored these, and the Linux kernel stored this information for 10 minutes, and after 10 minutes, the MikroTik routing tables was flushed and recalculated. But when you are received new routing information, for example, through OSPF, through ISIS, through BGP, through RIP, or because a link go down and you are change the active with inactive state of a route, the route needs to recalculate all the stored information. Exactly. Let's question wait at the end of the class. I think the same, because I have a presentation, and after I have the time to respond of the question. Now we are going to write our FIS configuration to get the same result as the previous static routing example, but with BGP protocol. The same, but with BGP protocol. So what is BGP and how BGP was wrote? The Border Gateway Protocol, BGP, was created in January 1989 by Jakob Rickner. I hope to read correctly this name. Is from IBM, and Kirk Logue from Cisco on the napkins. They was at the restaurant, and they discuss about a new BGP protocol to fix some problem, and they wrote the protocol on the two napkins protocol, and they said, hey, it can be a good idea to copy this napkin on another napkins, because if we lost the first napkin, we can have a second copy, and the second copy is what is showed on the Cisco office. And two napkins or three napkins, maybe it is three sides of two napkins. Okay, it's a funny story. I suggest to you two reference that I used and I use actually to better understand BGP. One is the RFC for 7,721 is free available on the internet. This is the link. And the second one is BGP from Theory to Practice, is a book from an Italian engineer, but is available on also on English language from Tiziano Toffoni, Flavio Luciani, and Antonio Prado. And they helped me to better understand some topics about Cisco and Juniper, but the standard is the same for everyone. So the primary function of a BGP speaking system is to exchange network reachability information. Please remember this: network reachability information is the key of BGP with other BGP system. And this network reachability information includes information on the list of autonomous system ISs that reachability information traverses. In this lab, we assume we have two different autonomous systems, the IS green, for example, and the S orange. An autonomous system is a network under a unique administrative control. For example, IS green is administered from Marco, and the IS orange is administered from Flavio. I cannot log in into the Flavio's routers to configure the routing policy of his router. And Flavio cannot log in into my router to configure my routing policy. How can Marco inform Flavio about his network? Marco can speak to Flavio and tell him, hey Flavio, you can reach the network 192.168.1.0/24 through my IS green. Marco wants to make sure Flavio is listening when he speaks, and that Flavio confirms that he has received the information. And Marco and Flavio are two BGP speakers, and they use TCP protocol to transport information reliably. So BGP use TCP as its transport protocol, and BGP process listens on TCP port 179. In my example, I used color to identify two different IS autonomous systems, but in reality, numbers are used to identify an IS. Just comment the network layer reachability information is prefix plus attribute. Yes, we discuss more deep into the presentation. The IS number are assigned worldwide by the IANA, the Internet Assigned Number Authority, to 5 regional Internet registers. Some numbers are reserved for private use, for example, from 64,512, I hope to read it correctly, and to 65,534. We will use the two autonomous systems inside our laboratory, 65M1 and 65M2. Okay, this is two simple autonomous systems that we are using in the lab. BGP protocol, very basic concept. Step 1, opening the connection over TCP. Step 2, establish a BGP session, open. Step 3, exchange BGP information, then update. And step 4, maintain BGP session, keep it alive. This is very basic concept to start to understand BGP. In router 1, Marco needs to create a BGP instance and define his autonomous system number IS65 and 1. Please note that the BGP instance are introduced inside the MikroTik from router S7.20 on the last September in 2025. And inside the router 1, I can write a routing BGP instance, add, this is the name of the instance, BGP 65 and 1, IS 65 and 1. In router 1, Marco, autonomous system, must create a BGP connection with router 2, Flavio, defining his autonomous system number. Router 1 and router 2 have two different autonomous systems. In this case, router 1 will establish a connection with a router that is external to its autonomous system. This is what is called external BGP, ABGP, external BGP. And the configuration of the router 1 of Marco, of my router, is this: routing BGP connection, add. I have to set a name of this connection, hello BGP with Flavio. I have to recall the instance that I've previously created, BGP 65 and 1. I have to set the remote address of the other BGP speaker, 10.0.0.2 is the other router. I have to configure the remote IS 65 and 2, this autonomous system. My autonomous system is defined inside the instance. And I have to define the local rule of my BGP session. It's external BGP because I have two different autonomous systems. If I need to redistribute, to inform router 2 about my network, I need to specify what network I have to put outside the BGP session, inside the BGP update packets. We will see this in depth. And with output.redistribute connected, I inform the BGP process on my router that I will send my network layer reachability information about my network connected. This is the case. Inside the connected route, I have some route, and I want to put out the connected route information to router 2. And this parameter allows the BGP process to send all routes that are of the type connected type to the neighbor router. And this is the flag dynamic active connected, my 2 connected route. Okay. In router 2, Flavio needs to create a BGP process and define his autonomous system number, and Flavio, router 2, needs to create the same configuration to connect with the router 1, with me. Inside the router 2, add the name BGP 65 and 2 with his autonomous system 65 and 2. This is the instance. And must create a BGP connection with router 1. Inside the router 2, Flavio needs to create a routing BGP connection, add the name, his instance previously created, remote address. Router 2 needs to contact me 10.0.0.1, sorry, and my autonomous system, remote IS 65 and 1. He's 65 and 2. He wants to connect with me, with this IP, and this with this autonomous system, 65 and 1. The local rule is external BGP because are two different autonomous systems, and Flavio wants to sent to me is connector route. Output.redistribute connect is the configuration. Please notice that the command on router S console is in line, but with the backslash I can go to the new line, but router S understand that this is a one-line command, but only wrote in multiple row. With Cisco or Huawei, you can have one row and one command. With MikroTik is only one command in one line, but with the backslash I can write multiple line. Okay. When the session is established, I can see the flag established inside the routing BGP session. So let's go. We try to create the same configuration inside the lab. I am using a virtual machine that I use for my training session about MikroTik, my training center. It's freely available on my website. We have only to register for free, and you can download this virtual machine. I will see you where you can find this. Is in Italian language. I hope to convert in English language in the future, and inside the website you can download this virtual machine. You can use VirtualBox because it's freely available all over the world without pay for the license. And my main goal is to permit to everyone to use this technology to grow. And inside this virtual machine, this is a Debian Lite based. I use the GNS free, and all the MikroTik CHR are already ready to use. I previously prepared this lab with router 1 and router 2, and I need to configure IP address. There is no IP inside the router 1. In the router 1, I need to add interface Ethernet 2 address 10.0.0.1/13 and add interface Ethernet 1 address 192.168.1.1/24 and IP route print. And now the routes know the two connected routes on the Ethernet 1 and on the Ethernet 2. So on the router 2, IP address print, there is no IP address, add interface Ethernet 1 address 192.168.2.1/24. Ethernet 1 is this, and add interface Ethernet 2 address 110.0.0.2/13. Okay, IP router printer. Now router 2 know two connected routes. So let's go and we configure the first BGP connection. Inside the router 1, this router, I need to connect with router 2. Router BGP instance, I need to create the first instance, add name BGP to router 2, 65 and 2, and I will define my IS 65 and 2. and connection, add name BGP to router 2. What is my instance? BGP to router 2, 65 and 2. And so please instance, I will change this name because it's not correct. Set 0 name BGP 65 and 1. This is my BGP 65 and 1 IS 65 and 1. This is my instance about my autonomous system. Sorry. BGP connection, and here add name BGP to route 2, 65 and 2. Instance BGP IS 65 and 1. The remote address is 10.0.0.2. This is the IP that I want to connect. And the remote IS is 65 and 2. My local rule is ABGP, and I want to output redistribute my connected routes. Okay, I have configured the connection with the router 2. And if I start to capture with the Wireshark, but it is integrated inside this virtual machine, I can see BGP when the session starts, the BGP communication. Inside the router 2, routing BGP instance, I need to create name BGP 65 and 2 and IS 65 and 2. And routing BGP connection, I need to configure the connection with router 1. Add name BGP to router 1, 65 and 1, only 2. Remember easily. Instance, my BGP instance, the remote address 10.1, 10.0.0.1, the remote IS 65 and 1, and what is my local rule is external BGP. Local rule is external BGP, and output redistribute connected route. Okay, the configuration is created, and now I can see the session print. The session is established, is communication is working. So with the GMS3, we can capture the packets on a link, and we can see if you remember previous slide, the open message, the establishes message, the update message, and now every 1 minute we can see the keep alive message used to keep alive the connection with the two routes. So inside the router 1, clear the console. Now IP route print. Now I can see that I have a new route 192.168.2.0/24 from BGP process. Okay, with BGP I have received the network of router 2. This is a very basic example to start to understand how BGP works. Okay, and in this case with the previous question. I also received my same network 10.0.0/20/13, but I have the same network with distance 0, and I use in the FIB this choice because is best instead of 20. Okay, and inside the router 2, IP route print, I have the same result. I received the network 1 via BGP. Okay, we can. I previously configured an IP on this virtual PC, and I can ping 192.168.2.2. This is the PC2, okay, and the PC2 is in timeout. Bad command, okay, there is a bad command inside the configuration of the PC2. Oh, I forgot IP. This is the command to configure this. I will need to reload PC2. Okay, now PC2 is ready to respond correctly. Sorry for the mistake. So Marco and Flavio are two BGP speakers. When they have established a connection together, they become a BGP neighbor, and we have created the lab in live. Okay, you can reproduce this lab with two route on the table, or with GNS3, EVNG, or other virtualization environment. I always suggest the guys to retry this lab, because we need to familiarize about this configuration and this topic. Marco, router 1, Marco received a BGP via router 2 Flavio network, and we have seen this. What is a network layer eligibility information? A route is defined as a unit of information that pairs a set of destinations with the attributes of a path to those destinations. Okay, inside the RFC you can see this. A set of destination with the attribute of this path. Inside the BGP update message, we can see here the update message. Okay, we have the path attributes and the network layer eligibility information. Inside the network layer eligibility information, I can see the network of can I reach through this next hop. Okay, sorry, one moment, please.
I hope we are following up closely.
Yes, okay.
Yes.
Yes.
Thank you.
Yes.
I think an interesting syntax of MikroTik.
Very interesting, Martin. Of course, Mike is enjoying this.
Okay, sorry for the delay, and now we can restart. So I hope this session is informative. So inside the network layer eligibility information, we can see the destination that I received and what is the next stop that I need to forward, where I need to forward the packets. Okay, and what is the IS path? In this case, we have a very simple example with only one IS path, but we need to start from the basic, with the very basic concept. And a set of a destination is this one, and the path attribute is the other information about the IS path to through, I reach that destination, and the next stop my next stop that I need to contact to reach. The set of the destination are system was IP addresses are contained in one IP address prefix that is carried in the network layer reachability information field of an update message. This is inside the book of RFC. Okay, I copy that sentence that I have studied inside this book and BGP from theory to practice. And the path is the information report in the path attribute field of the same update message. This is a list of the update message. Router 1 received from router 2 an update message that contains the path attribute and network layer reachability information. The next stop defines the unicast IP addresses of the router that should be used as the next stop to the destination listed in the network layer reachability information field of the update message. In the ISP field, inside the attribute, identify the autonomous system through, I can pass through more autonomous system, which route information carried in this update message has passed. And the next packets, the keep alive message, are used to maintain alive the BGP session with other. By default, this message is sent every 16 seconds. I need to convert from Italian to English. And if a peer doesn't receive this message within all the time interval, is 3 times keep alive, 118 seconds by default, it considers the peer dead and close the connection and removes from its routing table the received routes. If you, in the previous session of Martin, we discuss about OSPF, and in OSPF we have hello packets by default every 10 seconds, and after 4 times the link is unreachable. Okay, in BGP we have 16 seconds and 3 times. Okay, but BGP and OSPF is a different protocol. We will discuss about this and about other questions at the end of the presentation. To better understand the concept of ISP, the SPAF, let's add a new IS 65 and 3 connected to router 2. We have Tiziano that have wrote the book about BGP, and now Tiziano is connected with Flavio. Okay, with Flavio, Flavio and Tiziano have a network together, connected, and Tiziano have a private LAN and need to redistribute his network to Marco. No? Autonomous system, router 2 and router 3 will open the connections, establish a BGP session, exchange BGP information, update and maintain BGP session alive. Tiziano says to Flavio, hey Flavio, you can reach my network through my IP 10.2.3.2/13. The path of autonomous system is AS65 and 3, his autonomous system. This is the BGP update packets that router 3 send, and Flavio now automatically sends Marco 2 different BGP updates. One for the new connected route, because Flavio have a new connected route inside his routing table, because have an IP on that network, okay? And Flavio select the best path from his point of view to send out the network layer attribute information to the other peer. And the one for the new BGP route learned from Tiziano 192.168.13.0/24. And this is the BGP update packets that Flavio sent to Marco. Hey Marco, you can reach 10.2.3.0/24 this network through my IP 10.0.0.2, and the ISP is 65 and 2. I am the router one. I cannot need to pass through more than his autonomous system to reach that net. And the second BGP update from Flavio is, hey Marco, you can reach 192.168.3.0/24 through my IP 10.0.0.2, but the path is 65 and 2 and 65 and 3. Now I know that I can pass through two autonomous systems to reach that destination. Okay, it's different from the previous because I need to pass through one autonomous system to reach the second autonomous system. The BGP update contained for the first update is, and for the second BGP update, 65 and 2 and 65 and 3. This is the Wireshark packets that I captured from the lab, okay? And Flavio says to Tiziano,
Marco?
yeah?
I have little bit confusion about the IP. You are saying that 192.168.3.0/24. This is the network IP, okay? And the other IP on the other end, 10.2.3.2. Okay, what is the IP of this? Yes,
This
this one.
IP? This
Yes,
one?
yes, this
Okay.
one. Yeah, this one and like upside and
Yeah.
same
So
on the third
you're
one.
right. You're right because Tiziano, router 3, have the IP 10.2.3.2 in his interface, and have the network 10.2.3.0/30 inside his routing table, and he send to Flavio this network layer attribute information. Okay, this is the BGP update packets that contains this network and this network from router 3 from Tiziano. Okay, but Flavio reach 10.2.3.0/13 as a network, but Flavio have already that network that is connected because he have a IP inside this network that is directly connected, and Flavio select the best route that is best, what is connected, not what is received from BGP.
Okay.
I hope that I ever respond to you.
Okay, thank you.
Okay.
I have a question also.
See?
Just to ask, we've started on the BGP, no, the attributes evolution process.
Yeah, we will discuss more about BGP best path selection more deep in the next presentation. In this presentation, but in the next slide. Okay.
Okay.
This is in router 1, I have the same because I have a connector route and the same route but received from BGP. And this route is not active, is inside the RIB. This is the RIB, but is not inside the FIB. This route is not inside the FIB because it's not active. This is inside the FIB, but this one is not inside the FIB, it's not active. This is what I wrote in the first slide when I spoke about FIB and RIB, okay? So, now router 1 know how to reach 192.168.3.0, sorry, /24 through router 2, 10.0.0.2. Okay, now router 1 know how to reach router 3. And inside the routing table, Marco can read some interesting detail about that route. We can, inside the MikroTik router, we can have routing route print where BGP, and we can use print detail to see more detail. And now I can see the detail about BGP network layer reachability information that I received. And this is the network 2. In my live lab, I have created only router 1 like 2. And I can see the BGP session, the IS path, and the same network, but is not active. Okay, I can see more deep. Here I can see the network layer reachability information with some attribute. We will discuss more about this in the next slide. Okay, and Tiziano, the router 3, also know how to reach Marco network. Okay, Marco and Tiziano decided to connect directly to each other and become BGP neighbor, and Marco adds a new link directly connected with Tiziano in this case. Okay, 10.1.3, I use usually in my lab 10 as the link of the lab, .1 router 1, .3 router 3, to better understand the network, to follow my configuration. We keep in mind these rules, simple rules. Okay, now I have a direct link from router 1 to router 3. Marco sent the updates, BGP packets to Tiziano, and Tiziano sent the BGP packets update to Marco. And now router 1, Marco, know how to reach 192.168.3.0/24 through two different paths. One path is directly connected with Tiziano, the network 3, and another one is through router 2. Okay, and the router 1 selected the best path. You can see the active flag on the directly connected router 3, and the second one without the first one without the active flag. Okay, only one is active. BGP best path selection process. If the same prefix is received from more than one peer, this is our case, BGP select the best path from an algorithm that compare some parameters or attribute and choose only one. Okay. It's behind the scope of this presentation to explain all the BGP algorithm of BGP best path selection. It takes time, and on the MikroTik Help website you can find it, the best path algorithm from the point of view of MikroTik device. But let's examine two standards, common and most important attributes: local preference and IS path. Local preference is an attribute used only within an IS. It is not present in the BGP update message of external BGP peers. In our case, we have not seen this attribute inside the external BGP packets. It is possible to set or manipulate this attribute via BGP filters. By default, its value is 100. And BGP local preference, BGP prefer the route with the highest local preference value. This is the opposite side of the distance. I prefer the distance with minus distance. In this case, a router prefer the highest local preference inside the BGP. When router 1 received the BGP packets from router 2, when the packets are coming inside the router 1 add to the network layer LGBT information that attribute. Okay, it's not traveled from router 2 router 1, but is router 1, the autonomous system boundary router, that had this attribute. And if I have more route inside my autonomous system, I can send the network layer eligibility information, the BGP update packets, to other router inside my autonomous system with this attribute. Okay. And for example, if I have 192.168.30/24 via router 2 and local preference 200, and the other one with the 100, the 200 is the best. Okay. In our case of the lab, we did not manipulate the attribute local preference. The two routes have the same value, 100, and BGP can select the best path with this attribute because it's the same. Let's go to examine the next attribute, ISPath. ISPath attribute identifies the autonomous system through which route information carried in this update message as passed. BGP prefer the path with the shortest ISPath. BGP is a path vector routing protocol, and it makes decision based on the path. BGP doesn't know how know the topology inside an autonomous system. BGP also know only how many IS I have to travel through to reach the destination. I don't know if an autonomous system is small or big. I know only how many IS I traverse to reach the destination. Path vector routing protocol, and it makes decision based on the path, the network policies or rule sets configured by a network administrator. In this case, Marco, router 1, received this destination with IS path on one IS and this network layer eligibility information with two autonomous systems. Okay, and prefer the one with the shortest IS path. Is a path vector. This is the path vector, the shortest IS path. And in this case, if I use a routing route print detail where destination address to search only this specific destination, I can see two network layer eligibility information received, and one with IS path of one IS, another one with two IS, and the active is when I have only one IS. Can I manipulate that attributes? Yes. In router S, MikroTik, you can write a route filter that modify one or more attributes. And the goal is router 1, Marco, wants to go through router 2, Flavio, to reach router 3, Tiziano, instead direct connection. By default, local preference is added by the router 1 when received the network layer eligibility information for router 2. Now we are going to add an input filter to change local preference with value of 200. This is the routing filter rule section of the MikroTik router S. Add chain. This is the name that I use for this rule, BGP IS 65 and 2 input. It is easily to understand this the work of this rule. And the rule is this: if destination is equal 192.168.3.0/24, set the BGP local preference attribute with value of 200. Please notice that this is not the equal symbol, only the space. And accept. Else, if the destination is not this, accept without change the BGP local preference. This is the rule. And I need to apply this filter on the connection, on the BGP session, routing BGP connection, set. I want to change some configuration on already present configuration, and in this case, is not add, but is set. It's like edit, but Microsoft uses set. Set on the BGP to Flavio IS 65.2 connection, input dot filter equal BGP IS input, and I assign this filter to the connection. And now, in router 1, inside my router, I have the local preference 200 through Flavio, router 2, and 100 through Flavio. And I select the best is with the highest local preference, is my local preference, is a preference inside my route, inside my autonomous system. Local preference means this, okay? And I can manipulate the BGP best path selection, for example, with local preference inside my local route, okay? I can apply this filter inside my local device, not inside the remote device. I can work only inside my local route, local preference. And now in the routing route green detail where destination is this, I can notice, I can see active is the connected route to router 2 and not router 3. Router 3 is directly connected, but I want to prefer router 2. And then now I can see the attribute local preference to 200. Please notice that if the routes have the default value of 100, the local preference is not showed in this print command, okay? And 2S path, but best local preference, and I select this one. But I want to modify the BGP path selection in the remote device. I want to manipulate how other select the path to reach me. And I cannot configure directly the connection on the other router, but I can manipulate some route information of BGP update that I send out from my route. We have removed the local preference from our configuration, and the goal now is on Tiziano, will manipulate the Marco router 1 BGP best path algorithm to force receiving packets destined from his network through router 2 Flavio. Previous local filter, local preference is not applied. Now, I want to, from the point of view of Tiziano want to manipulate router 1 Marco to receive packets from Flavio and not from directly connected link. Okay, this is the goal. Tiziano will manipulate my routing BGP best path selection to receive the packet from Flavio and not from directly connected link. Okay. In this case, Tiziano can send out BGP update message that contain a network layer eligibility information attribute with a longest ISP. We have previously discussed about BGP's path vector protocol that select the local preference, and if the local preference is the same, select the ISP with the shortest ISP. I can add more time my IS number to please 1 minute, to make him believe that my direct link is longest in front of the link with the another router. Inserting your IS more time is called prepend. Example, with the IS path with 3 times my IS is a IS path prepend. And to apply IS path prepend, you must create a routing filter. This is the filter inside the router tree, routing filter rule, add chain BGP. This is a name that I choose for this rule. And the rule means if the destination is 192.168.3.0/24, from the point of view of the router tree, this is his local network connected. When the BGP update packets are forwarding out, are sent out, set the BGP path prepend 2 times and accept and put out this network layer 2 bit information. If the network is not this, put out the network, accept means put out the network. And now I need to apply to the BGP session this new output filter. This filter is in output. The previous filter is in input from the point of view of the router, because I need to manipulate the BGP update that I received in the router 1. Flavio, router 3, needs to manipulate the packets, the BGP update packet that are sending out, and in this case, output filter. Okay? And now, what router 1 see inside his routing table, router 1 see 192.168.3.0/24 IS path 65 and 2, 65 and 3, 2 and 3. And Tiziano send out to Marco the BGP update packets with 3 times his autonomous system. And from the point of view of router 1, this directed connection network is longest instead of what received from Flavio. And Marco select Flavio, router 2, to reach router 3. This way, router 3 can manipulate the BGP best spec selection inside other autonomous system. Okay, this is 2 more important and most common filtering used to manipulate BGP bus path selection process. What we learned about external BGP. When an external BGP peer received a route, it is freely propagated to other peers. When router 2 received the network of router 3, router 2 send out, freely propagate this network to router 1. Okay? Its IS is added to the IS path attribute. We can see that router 2 add to the IS path of the network 3 his autonomous system when the packets are forwarding out. And when the BGP peers are in different broadcast domain, next of attribute is changed to the external BGP session IP. In this situation, this is a broadcast domain. This is a broadcast domain. When router 1 is in a different broadcast domain of this, router 2 change the next hop received from router 3 and insert his next hop, because router 1 cannot reach this broadcast domain because it is in different broadcast domain. Chris wrote in the chat, he didn't mention weight. Yes, you are right, because weight is a proprietary attribute of Cisco, is not standardized, and my main goal is to speaking about standard, and Cisco Microtik support weight, but is not fully supported from other vendors, and my main goal is to start from the basic and from the standard. Okay, Cisco adds this attribute that is only local inside an IS, is not propagated, and not all the vendors can use weight. This is the motivation, because I don't insert the weight inside my presentation. Okay, but you are right. Okay. And how about IBGP, internal BGP? How does IBGP works? Okay. So I created a new lab. I can have the lab already prepared if you have the time to start the lab at the end of the presentation. And in this case, I use an external BGP from router 1 to router 2. And router 2, router 3, router 4 are inside the same autonomous system, okay? And router 4 is connected with another router. This router 5 is inside a different autonomous system, and in this case, is external BGP. Please, Evanson.
Evans, we suggested that questions will come at the end of the session. Let's give Marco time to complete, and then we'll have a Q&A session in a few.
Perfect. Thank you, Martin. Perfect. Router 1 and 2, and router 4 and 5 session are external BGP, because that session are established on the external side of the autonomous system, and BGP neighbor have different autonomous system number. We previously discussed about this topic, okay? And router 2 with router 3 and router 3 with router 4 are session are internal BGP, because that session are established on the internal side of the IS, and the BGP neighbor have the same IS number, okay? Appear in a different IS is referred to an IS, as an external peer, while appear in the same IS is referred to IS, an internal peer. Internal BGP and external BGP are commonly abbreviated as eBGP and ABGP. Let's configure router 1 to create a connection with router 2. In the router 1, I need to set the identity. This is a full lab documented in the presentation, and you can reproduce all the lab that I insert in the presentation, okay? To easily follow my presentation, I insert a simple schema, and you are here. We are on the router 1, okay? This is the router, and when I see the configuration, you are here inside the 3 different autonomous systems. Inside the router 1, I need to configure my LAN 1 and 2, 168.1, and the link local from 1 to 2, 10.1.2. Okay. And routing BGP instance, the name of the instance. Please mute the microphone. And the routing BGP connection, I need to create the connection with the router 2. BGP to router 2, remote address, remote IS, local rule external BGP. And in this case, I don't use the output redistribute connected, but I create a list of network, IP firewall address list. It is not a firewall. Is a menu inside the menu firewall, but is only a list, okay? Is like an ICL. Address list, add address 1 and 2, 168.1.0/24 list, BGP out network. This is the name of this list that contains a list of the network. Is only a list of the network. And inside the BGP connection, I can use output.network, BGP out network. I set this list in the BGP process, and BGP process know that inside the BGP update packets have to insert this network on the network layer eligibility information section. This is the explain. On the router 2, now let's configure router 2. You are here, inside the router 2, set the identity. Please set the identity, because with 5 router, if you don't use the identity, you can change the configuration on the wrong router, okay? I always suggest this to my students. I set the IP address of the link local 10.1.2.2 and the network 192.168.2 on the router 2. In the lab, I use router 1, network 1, router 2, 168.2, router 3, network 3, router 4, network 4, router 5, network 5, to easily understand and follow me on the configuration. Router 2, configuration with router 1. The remote address is the IP of the link local, the local link, and the remote IS is different with my IS, and in this case, local rule is external BGP, and the output network is what is inside the list. Okay. And now in router 1, the first router, I can see the network of router 2 when the session BGP is established. In the router 2, I can see the network of the router 1, and all is working correctly. So now starts to configure. Let's configure router 2 to create the connection with the router 3. But in this case, inside my autonomous system with the same autonomous system number. I only need to add the IP address on the interface Ethernet 1. Ethernet 1 is from router 2 to router 3, and configure the BGP connection to router 3. I don't need to create a new instance, because I need only one instance BGP, and with this instance I can create multiple connections. I need to configure the IP address and the routing BGP connection to the remote address 10.2.3.2. Remote IS is the same, and in this case, local rule is internal BGP. I need to drink some water because I have 8 days of full training every day, and my voice calls some water. Local rule IBGP, internal BGP, and output network is BGP output network is the same on the previous list that I previously configured, and I only need to recall this list to send out my local network to other peer. Let's configure router 3 to establish the connection with router 2. And in the router 3, I set my identity. I set the IP address on the link to reach router 2. I need to configure the network, local network on the router 3. I need to create the list of my network. I need to create the BGP instance with my autonomous system. The autonomous system is 65 and 2. And I need to create a connection with the router 2. I am in router 3, I need to connect with router 2. I set the IP address, the 10.2.3.1. The remote IS is the same IS that I have. In this case, the local rule is internal BGP. And I want to send out my list BGP out network. Now, inside the router 2, the session BGP is established. Inside the router 2, I received the network from router 1 and the network from router 3. And router 2 know the network 1 and the network 3. Okay. Please notice that in this case, the distance is different because in external BGP, the distance is 20 inside the MikroTik router S. And when the route is received from internal BGP, the distance is 200. Okay. I can see the IP routing table with print command, and if my eyes see these two different distance, I already know what is external and what is internal by default. Okay, if I change this with a filter, it can be a different distance, but by default is will have this value. From the point of view of router 3, the route in the middle, I received the network 2, and I received the network 1, but is active? No, is inactive, is not active, is inactive. I have this network, the route information inside my RIB, but I cannot use this network reachability information on the FIB, on the forward information base, because it's inactive. And why is inactive? Because router 2 send me the network layer reachability information with a next stop that I don't know. I don't know how to reach 10.1.2.1. Okay, I don't know this next stop. The route from router 4 is inactive, and this is a typo. Is from router 1. Sorry, and a router advertised to its IBGP neighbor what it received from an IBGP neighbor. What this means? Router 2 send out to router 3 the network received from router 1. But when a router have a session, a connection in internal BGP, don't change the next stop attribute. In the previous slide, the previous part of the presentation, we learned that external BGP changed the next stop. But with internal BGP session, the route doesn't change the next stop, because inside RFC is wrote that that the routes need to know the internal topology with an IGP, an internal gateway protocol. For example, OSPF or ISS is out of the scope of internal BGP to distribute all the routes inside the autonomous system. It's right, because it's designed as AGP, external gateway protocol. The main function of BGP speaking is to exchange network reachability information with other BGP systems. But we can use BGP inside the autonomous system. And how can fix this one? This is the path attribute received from router 1. Next stop 10.1.2.1. This is the IP of the next stop to reach the destination. And when router 2 send out this path attribute, send out with the same next stop. And I received this network. I don't know how to reach this network. By adding router 3 the route to reach the next stop, I can fix this. For example, in my example, I will not cover OSPF or ISIS topic in this presentation, and I used static routing to better understand to everyone this concept. I add how to reach 10.1.2.1, the next stop, through router 2, quindi 10.2.3.1, and now my router have configured the route as active, dynamic active BGP, because the router know how to reach that gateway through another route. Okay. Or by changing router 2, the value of the next stop attribute, we can configure the BGP process to force the next stop as next stop choice as a force self. I can configure router 2 to send out the BGP update packets to other internal BGP, changing the next stop attribute with force itself. In this case, I receive the network 1, but with the next stop of the router 2. I can configure this one. I can fix this in 2 different modes. Okay, I suggest in this case to use the next stop choice for self, but it's important to better understand how BGP works with internal BGP, because you can stay in this situation, and if you understand this particular functioning, you can fix this model everywhere in different vendors' device. Okay, and internal BGP next hop now is changed with this network and not this IP. Okay. This is the network layer reachability information 192.168.1.0. This one, when passed through router 2 in internal BGP, that by default doesn't change in the next hop, I can force router 2 to change the next hop attribute, okay, to reach router 3 network 1. Let's configure router 3 to connect with router 4 with the BGP. In router 3, I only need to add an IP address on the interface to face on the router 4. And the routing BGP connection, I need to configure the connection with router 4, remote address of the router 4. Remote IS is the same of my autonomous system. In this case, the local rule, internal BGP. And I need to send out my BGP output network is the list that I previously configured on my router. And now on the router 4, I need to configure the connection with router 3. Router 4, system name, IP address on the link, the IP address on my LAN on the router 4, the list of the network that I want to send out by BGP connection. I need to configure the instance defining my autonomous system, and I want to connect with router 3 that is inside my IS, that I use the same autonomous system, and I need to configure the remote address of the router 3 with the remote IS is the same of my autonomous system. In this case, the local rule is internal BGP. And I want to send out output network, what is inside the list, okay? And inside the router 3, routing IP router, now I can see in router 3 that the router 3 know the network 4, 192.168.40/24, 10.3.4.2 is the next hop of the router 4. Is internal BGP with distance 200. But inside the router 4, what's happened? Okay, inside the router 4, I receive only the network from router 3 and not from all the other devices. Why? So, please. Why? Why is this? Why this? Router 3 receive only the router 4 receive only the router 3 network. This green one, but not the first and the second, with the wrong icon. By default, an internal BGP speaker do not redistribute routes received from another IBGP speaker. And this is the case. Router 3 send out his network to router 4, but the router 3 doesn't send out the network received from another internal BGP peer, router 2, that know router 1. Okay, this is the case. Inside the RFC 4271 border gateway protocol, there is this update send process information. When a BGP speaker received an update message from an internal peer, the receiving BGP speaker shall not redistribute the routing information contained in that attribute message to other internal peers, unless the speaker acts as a BGP router reflector, but we will discuss in the next chapter of the presentation. We can fix that in two ways, with IBGP full mesh or with IBGP router reflector. With the IBGP full mesh, it means that every route needs to create a connection with all the other routes in this lab is easily to create, because I only need to create a connection with router 2 and router 4. But if I have a big autonomous system, I have to create a very huge amount of direct connection, and it's not scalable, okay? And if I want to create the full mesh, the configuration is this. In router 2, I need to create the connection to router 4, okay? And in router 4, I need to create a configuration with router 2. And in router 4, now I received router 1, the network 1, the network 2, the network 3, a routing route, print the detail where BGP. I filter only the BGP routing information. Okay, now I fix the problem with the full mesh. But it's not scalable, and we will use iBGP router reflector to create a network more scalable. Unless the speaker acts as a BGP router reflector, this is a specific RFC. Split horizon is an inbuilt feature in BGP. Exactly, is so-called split horizon. Yeah, is inbuilt features in BGP. Is brought inside RFC. Evanson Mugo wrote in the chat. Yes, you are right. This is so-called split horizon. What is a reflector? I put some example of reflector in our life. This object reflects something that is not originated by him, but which he has received. In this case, is a reflector of light, not light, okay? And I can use a reflector. I use the same icon to better and to easily understand this functionality. I can use a reflector inside my autonomous system, and when I receive from router 2 the network 2 and the network 1, because he reflects, he sends out the external BGP network, I can reflect this network to the router 4 automatically. Okay. Router 3, router reflector, I need to change some configuration, set BGP, this is my connection. Local rule is not only internal BGP, but is internal BGP with router reflector rule. And next stop choice, I need to force self as a next stop in this case, because router 4 doesn't know how to reach network of router 2, for example. But usually router reflector is used without force self, because it's a node that is not a forwarding route. But in this lab, I need to create the next stop choice for self configuration. Finally, router 4 received the routes to reach router 1, router 2 network via router 3, because router 3 reflects what is received from router 2 and router 1. And it works. So let's configure the router 4 to exchange the network layer 2-bit information with router 5 that is outside my autonomous system, is an external BGP. I need to create in the router 4 the configuration to connect with the router 5. I need to put the IP address on the interface. I need to create the connection with this IP. And I need to set the autonomous system 65 and 5, and it is different from my autonomous system, and in this case it's like external BGP. And I will send out output network, what is in the list BGP output network. And I need to modify the session in the router 3 to force the next stop choice. And in the router 5, I need to create the connection to router 4. Router 5, I need to configure the IP address on the interface, the IP address of the network. I need to create the list of my network, and I need to create the instance, the connection from router 5 to router 4, setting the remote address of router 4, the autonomous system of router 4, is different autonomous system of my autonomous system. In this case, is external BGP and the output network when what I want to send out to the other IS. And now in router 4 routing table, I have all the route. In the router 5, I have all the route 1, 2, 3, 4, 5. Okay, and the router 5 routing table, routing root, print the detail where BGP, I can see router 1, the network 1. From the point of view of the router 5, I can see the SPAF 65 and 1, the original IS that originate where this network is, and the 65 and 2, that is the IS that BGP update pass through to reach router 5. Okay, and I can see the other, the network 2, 3, and 4 are inside the same IS, and I can see only one IS because this network layer reachability information BGP update have not passed through more than it is one autonomous system. Now we are at the end point of the presentation, and we will start the question and answer soon. Gas station connectivity. We can discuss about the start of the presentation, about the case study. Now it can be more easily to understand how to solve the initial problem of connectivity and redundancy automation. In the previous lab, the start of this presentation, I have a point of sale with an internal BGP connection with the core router and a new connection, router 1, with the manager office with internal BGP because it's inside the same autonomous system, the same organization. But the payment system is a different organization, and in this case, I need to create an external BGP connection to reach out, to reach the network that is inside the different IS. Okay, this is internal BGP, external BGP. On the router core, I needed to configure the router reflector functionality to reflect the network that I received from external BGP, and the next stop to force P1 to use router 1 as a next stop and not this link that P1 doesn't know. And if I need redundancy, I can use a new router core, router 2, with 2 VPN, with the internal BGP. I can use two next stop, and I can use local preference to prefer one route instead of another route, and I can use external BGP. In this case, with the keep alive, okay, with the keep alive functionality of BGP, I can notice, I can see if a link VPN go down because I can't receive the link, and automatically the routing process select a new next stop best to reach this destination. Okay, and I can use IS path prepend to select what link I want to use to reach the external BGP autonomous system. So this is the introduction about BGP. There is more about BGP. This is the first part of a big iceberg to understand. But for example, if you are using a VPN in the data center via a BGP, you can send out VXLAN information to connect at layer 2 devices with layer 3 router, for example, layer 3 switch. And VXLAN provides encapsulation for layer 2 frames across IP data plane, and through a VPN via BGP provide a control plane to distribute MAC and IP mappings. The topic is this: BGP is not only for network is with BGP, we can use BGP to forward a lot of information. For example, MAC and IP mappings of a VPN. This is the proof of concept of a VPN, for example, but is behind the scope of this presentation to explain a VPN. And I hope I have given you at least one valid reason about why you should learn BGP even if you are not an ISP, and I hope to give to other the main principle of the please move to the microphone, the base principle of the BGP functionality. BGP can be scary. I was scared about BGP for a lot of time. I put myself on the book that I used BGP from theory to practice. I used the RFC, I used the lab, I used Wireshark. Wireshark is the main the software that you must use to better understand BGP. Managing BGP can be difficult, especially at first. Please remember this and don't get into a complicated project at the beginning. And remember that never say never, because limits like fear are often just an illusion, said Michael Jordan. Don't believe that I'm not able to understand BGP. You can understand BGP step by step, and you must put the first step to understand BGP. And if you believe you can learn BGP and you work hard every single day to do so, I put in the biggest, and you work hard every single day to do so, you will become a BGP expert or whatever you think you want to become. I was really great to Martin to invite me to become a mentor in his program. I started to follow to see his videos on YouTube. In the previous part of my life, 2 or 3 years ago, I started to do the same in my Italian language to my community, to permit people to start to learn my network. I use MikroTik because it's available, is free of charge to start, is easy to use at the beginning. But the point is to grow people, okay? And sincere thanks to Tiziano Toffoni of Res Remoli. I meet him in person 2 years ago, and I have a very informative meet with him. He wrote the book, and one of the co-author, Flavio Luciani, is a CTO of Namex, is an important inter-exchange point in Italy, and Flavio inserted me with Tiziano inside his school of advanced networking to train another technicians about routing, switching, PPPoE routing information. And 3 years ago, it was incredibly goal for me, but I am here because I put myself every single day on this topic. So thank you for your time. I always encourage my students to challenge yourself to grow, and I hope this session was informative. And now I have the time for the question and answer.
Thank you so much, Marco. That was a very informative session from the beginning, the gas stations, and you've used a very easy logic to help us understand BGP. We've all learned a lot from the session, and we are very grateful for that. Guys, the floor is open. You have 1,000 reasons, not just one reason, but 1,000 reasons to learn BGP. So if you have a question, just unmute. First raise your hand, and then we will pick you, and then you can ask your question. If you posted your question on the chat, you can also unmute and just ask it. Maybe we have missed your question in the chat.
I can read some previous question. JK said, can you explain a role of ISX enable on interface loopback 0 in a BGP enable routes? This presentation I can't use. I choose to not use ISIS because it's an AGP. It's out of the scope you don't know to use ISIS to learn BGP. The main goal of this BGP session is to permit to everyone to understand BGP, even if I don't know ISIS or even if I don't know OSPF, for example. Okay, this is my first goal. It is, Stefano, it is possible to have the recording of the last videos of OSPF. Stefano, if you can see, you can use YouTube and Live8 technology, and on Live8 technology, I previously see that there is the OSPF videos. And
yes, the session, the previous two sessions, I can reshare the link. If you are on our WhatsApp platform, I will reshare the links for the recording for the person who is asking about the OSPF session. You can continue, Marco.
What? Sorry, I don't understand.
I believe he's asking about the recording of the OSPF session.
Yeah. The previous session about OSPF. Yes, I see that is available on YouTube channel of Live8 technology.
Yes, true.
Local preference just distributed inside the IS to determine the exit point. Exactly, Evanson Mugo. And I don't mention weight because it's not standard attribute. MikroTik support weight, but the main goal is to explain the standard of the BGP, and I choose to not explain. Martin, I search about Huawei routers that I found that they doesn't support weight. I am right?
Yes. On Huawei devices, we also don't have weight, but we have normally we have some proprietary attributes also on Huawei, but they don't support weight.
Preferred value.
The preferred value.
Yes, we have the preferred value. Thanks for mentioning that.
Okay. It is possible to share the presentation here too. Yes, I can send the presentation to Martin. I can send the file in the chat. I don't know if it is possible.
You can drop it on WhatsApp group.
Okay.
No. Martin.
Yes.
Maybe what I wanted to say is
yes.
that before any BGP process, evolution process starts.
Yes.
That next hop has to be reachable. That if it's not reachable, we are not going to evaluate. The process is not going to start.
Yes, that is true, Evans. And remember, even Marco mentioned about the next hop when he was demonstrating how the route exchange happens. Yes, so that is very true.
I just wanted to add that.
For case we are using directly connected interface, right? Not loopback. So if we are using perhaps loopbacks, then maybe consider static routes to have reachability to those next hops.
You can use the loopback information, the loopback interface, but to use a loopback interface, you must use OSPF or ISS to redistribute the loopback or static route. And in this case, the technician or the people need to know these topics. And I want to start from the very beginning of the BGP without insert things that can confuse someone that doesn't know how loopback works. Okay, this is the why I don't use loopback. But you're right, loopback is the next step to better use eBGP or ABGP with static route to reach the other loopback. Yes, of course. Martin, I can't upload the file into the meeting, but I sent to you on WhatsApp
Thank you.
your WhatsApp the presentation. Okay, you can
Uh,
share.
Okay.
Marco, I have a question.
Yeah.
Yes, Said.
Yes, Marco, you have defined about the VLAN and X VLAN. Can you tell me about what is the major difference between the VLAN and X VLAN? Because both protocols are, I think, layer 2. We are
Yeah.
using on the layer 2 because VLAN we are using on the layer 2 devices. So what is the
Yeah.
main difference between the VLAN and X VLAN?
Yeah.
Where we will use the VLAN and where we will use X VLAN?
Ok, allora, so um, I need to create some. Are you seeing my schema?
Yes,
My
yes, yes,
okay.
yes. Yes, your screen
So
is sharing.
if you if I have two switch, okay, I can have a PC1 and PC2, okay, connected to the switch. This interface is an
Access port.
access port, exactly,
Yes.
access port, and this is a trunk. Okay,
Okay.
this is the frame at the layer 2 with the destination, the source, okay, the type or LAN, the payload, and
Yes, interesting.
the frame
Makes sense.
sequence. Okay, and when you are using the VLAN, we add an information here, the tag here. Okay, we add an information here. Okay,
Yeah.
inside the frame method. When we are using VXLAN, we have a frame at layer 2, and with VXLAN we can use a router and not a switch. Okay, and we need to propagate the layer 2 outside another router, but a router cannot propagate broadcast, for example, because the router stop broadcast domain. The switch propagate broadcast domain, the router not. And I need to encapsulate this layer 2 inside an IP packets. Okay, this is the IP packets, okay, that is forward out to the router, and I can put this layer 2 inside the payload of layer 3 packets. And these layer 3 packets can travel through a lot of router, okay? And when the packets reach the final destination, inside the payload of the IP packets, I can follow these layer 2 packets, and I can decapsulate the layer 2, and I can send out only the layer 2, okay? But with the switch, I cannot do the same because switch is inside my network, only inside local network, the switch. Router is outside my network, and I can reach remote network. And the VXLAN is, you can see VXLAN as similar VLAN tag, but layer 3. I need to put some information to identify this frame Ethernet. VXLAN, VXLAN do this work. Okay. I
Okay.
hope.
Yes, yes. Okay, you mean if we are configuring on the layer 2 devices, we will just configure VLANs. And for example, in the network layer 3 device involved, for example, any router involved, then we will configure X VLAN.
Exactly. In the data center, VXLAN are using to forward layer 2, for example, through layer 3 domain to avoid spanning tree and broadcast and so many other problems.
Okay, okay. One thing more. What is the difference between the tag and untag frames in the layer two?
The tagged and untagged frame.
Yes, it's tag and untag data. How they
Uh,
will communicate?
the tab. So,
Tag,
do you
tag,
mean
tag.
it's wrote in the chat the terms?
No, I am saying about the tag.
The tag, this one.
Yes, 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 yes. This
Okay.
one. This one.
The tag is inside a frame item. For example, you can use the tag type 0x or 0x. This is two type of VLAN tag. There is a more type, but this is the two common type of the VLAN tag. This is when the frame is in access of the switch, you can add the tag, the trunk transport the frame with this tag, and the access when come out, remove this tag outside. Okay, this is where the information at layer 2 are added. In VXLAN, you can travel frame Ethernet without tag, or you can add the VLAN tag. You can transport the frame Ethernet with the tag to add the VLAN tag inside the VXLAN. VXLAN transport layer 2, and inside layer 2 you can have the VLAN.
Okay, okay. You mean we will use
I,
untag
s-
data on the
I-
layer two?
Yes, but you can use tagged frame, and you can forward out VLAN perimeter with VLAN tag with no problem. Is
Okay,
a transport of layer 2 information with the information inside the layer 2. Okay. I suggest to you, I understand that it is not easy to understand this part, but with Wireshark, you can see the magic inside these protocols. Okay. Please
okay,
do the lab with Wireshark, and you can see the magician.
okay, okay, okay. Thank you, thank you.
Brother Marco, I have
You're
a
welcome.
question, please.
Yes.
You know, on microchip router, if I put, for instance, I put port one, I mean, from port 2 to port 4 into bridge mode, what does that mean?
Inside the microchip, are you create a bridge?
Yes, I put port 1 from port 2 to 4. I put it into bridge mode.
Yeah, but in this case, you are using a switch, not a router, because when you are using a bridge, you are creating a layer 2 device. Okay.
Okay,
And
okay.
the forwarding is with the layer 2 statement is about MAC address, and other information is not about routing. If a device have the same subnet mask, if my IP with subnet mask, I have a network address and the destination IP is inside my same network, I can reach this device because I directly connected with other. If the network address of the device that I want to contact is outside my network, I need routing to reach the device. I need a router, not a switch.
Thank you so much.
You're welcome.
Kennedy.
I see one hand on Kennedy.
Let's go with Tony. If Kennedy is not ready, Tony, you can ask your question. And please, let's focus on BGP so that we may not be able to address all the questions. So let's focus on BGP.
You're right.
Yes, Theophilus.
Hi, Marco.
Hi.
Okay, thanks a lot for the good presentation. My question is on the route reflection. So my question is, why is it that as much as the RR reflects out to all the client routers, it is never used like a transit router, like you see the same traffic from all the client routers passing the route reflector.
You are asking about why I use the router free as a router reflector that forward
No.
packets.
Okay, my question is, why is it not used like it doesn't work like a transit router? You may find like links to maybe to a route reflector, might be around 10 G, but the amount of traffic that you are passing through on the network, it could be even coming even up to 100 gigs.
I think that you are asking about the router reflector. The correct design about the router reflector is this. For example, I use the simple design that I use in the slide to easily understand some question about BGP, internal, external BGP, internal BGP. But for example, router 1, router 2, router 3, router 4, and router 5. The router 5. The current configuration is this one. Router 2 send the route to router reflector, and router reflector send the route to router 3 and to router 4. Okay, and router 2 send the network, for example, 192.168.1.2/24 with next 10.2.3.1 and 10.2.3.1, and router reflector reflects this route to router 3, and router 3 learn 192.168.2.0 that network through 10.2.3.1. And when the router 3 forward out traffic, not use a router reflector as a gateway, but use router 2 as a gateway. This is the correct implementation of router reflector. Router reflector only forward BGP updates, not forward packets. Okay, but in my case, to easily understand the topics and how to use a router reflector to fix the problem, I prefer to use router reflector to make the presentation simple as possible.
Yeah, I believe Bitok, what we are trying to avoid is suboptimal routing of some traffic, because you don't want all the traffic, for example, R2 sending to the route reflector and then route reflector sending the traffic to R3, when we can send the traffic directly from R2 to R3. So we are avoiding that suboptimal routing by avoiding the route reflector participating in the traffic forwarding. Just an addition of what Marco has already explained.
That is now, if maybe a contractor, that is the add path feature.
No. The add path feature is different.
Oh, okay.
Yeah, maybe we can discuss about it in the upcoming sessions.
Okay.
Yes. The other part is different. It's mostly used for load balance.
Yes. Tony or Bitok, you still have a question? It's clear?
Yes, it's clear.
Thank you.
Thank you.
Eliakim, your hand is up.
Okay, I just wanted some clarification. Marco, thank you so much for the incredible session today.
Thank you.
I just wanted to understand if the MikroTik, you can use the web GUI to do the BGP configuration instead of the
Oh, yeah. Of course. In my lab, for example, I use management is only a link, for example, like you will connect your PC to the router, and with this you can use Winbox or web interface to configure the router. But I prefer to use command line because command line need to understand what you are writing. Okay, but visual interface make you easily to make a mistake because your eyes follow the buttons and the fields. When you have to write, you must understand what you are writing, or you must thinking about what you are doing. With visual, you can follow picture or other stuff that is out of the scope of this presentation, because my main goal is to make you to make you understandable what you are doing, not only to cut and paste. Okay, this is my personal choice as a instructor. But you can do the same routing, BGP, and the connection and the template, the instance, and the section is available on the Winbox, and now the web fig, the web interface, is very straightforward, is very near to the Winbox, is the same, the web fig and the Winbox.
Okay, Mike.
Mine is just a comment and not a question either, but I just want to say thanks to Marco for the way he presented. Now looking at the ROS, that's a MikroTik basic user. I'm a basic user of MikroTik because I'm here. So I'm happy to see you bringing this. Martin, thanks so much for bringing Marco on board, because I know internally we have engineers who have been trying to understand MikroTik, and I think Marco has given us a way forward to demonstrate using a different vendor. And now when we come next time, we have a topic regarding the issue of using multi-vendor approach. I think now it will be easy for us as we prepare for the next sessions, that Marco has given us a way forward, looking at MikroTik and comparing with other manufacturers. You see that the understanding, the approach is the same. It's only the brand, the name, and whatever that changes, but approach and the principle remains the same. So Marco, thanks so much for that.
Thank you, Mike.
And beside that, I wanted to know, we may have our engineers maybe on board who may want to get certified in MikroTik. I'll request that before you sign off the meeting, maybe you'll give us a way forward on that. Those who may want to be certified in MikroTik. I currently have MTNA and MSRA, but I'm looking forward to other levels, to level 3, 4, and 5, so that I can advance. So I think you also give us a way forward on that. Once you have done your presentation, give us ideas of how other people who are interested in MikroTik can get certified. Thank you.
You're welcome. Thank you for your feedback. And my goal for this presentation is now is with the configuration that I wrote is with MikroTik, but from this lab we can change, for example, router 1 or router 5 with Cisco, with Huawei or Juniper to obtain the same result. Is the start, the point of start to know how different vendors works. Okay, this is a lab to learn BGP and to test other vendors. Yes, I am on the WhatsApp community group of Lifei Martin, but my main work is training in the class with people, and I have a very small amount of time to follow the chat, the group. Okay, when I have the time, I read and respond, but I cannot be fast to respond because this is my full-time works. I love what I do with my guys in the classroom, and I fully dedicated with the guys in the class.
I have a question. Huh?
Yeah.
No, no. In terms of split horizon, how it applies to many protocols, huh? Not only to BGP.
Yeah.
Now, with split horizon, I think what I've seen is that different vendors, say with Cisco, it's split horizon is a something that is applied. It's a default configuration, not even a configuration, but it's a different. It's a default feature internally.
I
And
don't
then
know Cisco to respond to this topic.
no. What I'm saying is that is Cisco, and then you can go to Juniper, Huawei that way. But what I've seen is different with Nokia. You have to apply it on the configuration.
Ah,
Mm,
it's
maybe Martin,
interesting.
maybe Martin, maybe, uh, it's a
Yes, 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 Evan. So Nokia, you need to run that split horizon command manually
Ah,
for
it's
it to
not
take
applied by
effect.
default.
Yes, yes, especially for the route exchange between external BGP neighbors. They may re-advertise the route, so you need to apply the split horizon command manually on all the devices that you've configured BGP on. That is the case.
okay. Because
Yeah.
I noticed that, and say these are the providers is different, huh?
Yes, yes, yes. I
Mm,
think
mm,
all providers, they are kind of different. They have their own unique
mm,
features. Some of them they are default, some of them you may need to do some configurations.
okay. So something I noted. That is
Yeah.
why I asked.
Okay, okay, okay. Yeah, you need to do it manually.
Yeah, okay.
Sahid, I see your hand is up again. You can.
Yes. I want to just clear one thing.
Yes.
I want to execute different labs, okay? And ENSP has limited future. So, what is the best tool for simulations of the Huawei and like other Cisco vendors? I
Ah,
want to perform the labs because
good question.
Marco advised
Uh,
me to
good
perform
question.
the labs. So that's why I
So
want to perform different labs and learn different things.
So good question. I did a presentation at Microsoft Professional Conference 2 years ago in the 2024 about how to improve yourself about the network topics using network simulator. I did a very deep dive time in my life to find the best network simulator, and I use a lot of simulator, ENSP. ENSP, you can see a lot of video of a great video from Martin with ESP is limited to use in Windows platform.
Yes, every command you
Uh,
cannot execute on the ENSP. There
uh,
are some restrictions and
uh,
limitations.
and this is a limitation because, correct me, Martin, but is not fully the system operation system, but is a part of a provision system. And if you want to deployment a full configuration, you need a physical device with Huawei. You can learn a lot, but not full command on
Yes.
Huawei. This is
So that's
my.
why I want to different simulator which every command can be executed.
So I love the standard because the standard give you become you be- give you the freedom, okay? And in my case, I use a Linux machine, and in the Linux machine, if I use the top command, I can see that the router S is inside the QEMU instance, And QEMU is an hypervisor features of Linux used, for example, from Proxmox, and is a standard model to use the virtualization. And you can use everything to virtualize the device. For example, I use some Huawei images on Proxmox because, for example, EVNG under the hood use QEMU. This is the same, is a Linux machine, Ubuntu with QEMU that run an image. There is a front end from EVNG, there is a front end from GNS3, there is a front end from Cisco CML, but under the hood is Linux with QEMU. Okay, I choose to use GNS3 on my virtual machine because it's a front end to configure the QEMU virtual machine, and I can set up all the RAM, the virtual CPU, the hard disk image, the CD, DVD, the network interface, and of course, the flag of the QEMU to use some type of acceleration of the virtualization. In my case, I need to use Tiny Code Generator is a software engine and not hardware engine. Is limited features. RouterOS is light. It's not a problem. But if you try to use Cisco or Huawei or Juniper with these features, it cannot run because it needs the nested virtualization. I suggest to use GNS3 bare metal inside a server or a PC to get the best performance that is required to process image that is huge, too powerful to use.
Okay.
Okay. I hope to explain your question.
Again, if you can build your own lab at home with hardware from different vendors, that is the best. But of course, it's expensive.
GNS3 is best. GNS3 is best.
GNS3 is one of the choice, the best. You can decide what is the best from your point of view. For me, GNS3 is the best because it's free and available. I run inside a Dell refurbished server, Dell 613 refurbished with the 2 Xeon CPU. I run a lot of 200 routers, RouterOS for my training session. This is my choice, but EVNG, PNet Lab, CML are another good choice. GNS3 is my choice because it's freely available for my students and do what I need. And for example, the most important features that I search inside the simulator is not the graphical GUI interface, but if I can see inside the packet, because inside the packet there is information. When you know where the information is stored, you can learn, you can grow, you can understand what you are clicking about GUI on the router. Okay.
Okay. So once I will download the GNS3, any other tools also can be integrated with it, and other software also will be downloaded, like VM and other.
GNS3 is composed in the 3 different parts. One is the GUI. This is the GUI. One is the server. And you can use an image that is run on the top of your local machine. And another way is to connect the GUI on a server that is on different server or multiple different server. You can connect multiple different server for create a very large topology. Okay, and I can use all-in-one to to easily start for my students to use virtualization with some limitation, of course, but with this device, this virtual machine with VirtualBox, you can create a very large topology with RTOS is light. RTOS is very light to run. Other image are very strong. For example, if you want to start to learn about Huawei VRP,
Yes, because I have 5 year experience in Huawei. I worked with Huawei more than 5 years.
I bought some refurbished IR 1220. Is very cheap router. You can use MPLS, BGP, OSPF, everything inside this very cheap router with some limitation, but it is a good way to start to learn.
Yes, yes.
Martin, I think.
Hello, brother Marco.
Martin,
Let's
Hello?
go one by one. Evans.
I
Okay.
think maybe if you can proceed with the chat, it would be very helpful so that if you have a question, you can put it down so that it can be picked from there. Whatever feedback you get, it will help.
Sorry, I don't understand your question. Martin, you can
Come
help
again,
me?
Evans. Come again, Evans.
And if you can proceed with the chat,
Okay,
if
actually, we are almost at the end of the session, so that's why we are now allowing guys to unmute and ask their questions directly. But Marco, you have a question in the chat. Someone is
Ah,
asking, that is Oscar, which training are
which
you
training
giving?
are giving? Oh, some very difficult question to explain. I do training in my training session in Italian language. I translate all the documentation in Italian language to help my students to understand the topics. English language is not easily to all the students, and I help my students with translating in Italian. And I start from zero. I created a course, Zero MikroTik, and MTCNA, MTC Array is about routing, static routing and dynamic routing with OSPF, security course, traffic control course for use, for example, firewall manual rules, queue for limitation and shaping the speed of the devices, the user, the customer, and wireless. One of the topics that I love is wireless, and the verity is inside. I see VNA, for example. I encourage a lot of students. Uh, we have Eduardo connected with us that he growing about wireless and networking is a huge amount of topics. You can bring only one and you can mastering one at a time. Okay, and of course I started about BGP and MPLS for the internet service provider topics. I am working to build a very interesting lab to explain how about an ISP works with multiple inter-service provider upstream with an IXP, Internet Exchange Point, with the PPPoE connection from the customer, with the transit with external BGP, with the radius. MikroTik permit to create a complete lab with all the technologies, and I have not the time to do in 1 year of all the course, and it's a very strong work to look to forward out. But give me um, give me give me give me give me happy when I see my students growing up. So next question.
Martin. Motiva, I see your hand is
Hi,
up.
everyone.
Hi.
Firstly, my apologies for landing late. Oh, sorry, guys. Can you hear me?
Yes,
Can
yes,
you
we
hear me,
can
guys?
hear you. Yes, yes, but you are
Yeah,
breaking.
yeah.
Yes. So firstly, I, oh, sorry. I apologize for coming in late. I was quite occupied. So my main question is, what is the true function of the PMTU in BGP?
Mhm. P is a provider. PE is a provider edge. For example, in this the topology, router 2 is PE, is the provider
No,
edge. Is this your question?
no. What? No. What I'm talking about is the Path MT discovery.
Sorry, I don't understand.
Can you hear me now?
Yes, much better.
Okay. So my question is, what is the true function of the PMTUD or the Path MTU discovery? I've seen in Cisco it's enabled by default.
Sorry. I read in the chat. Pet M2 discovery. I have. This is out of the topics about BGP, but is the fundamental about network. I created the MTU training as a file that I can share with us in the chat. It's a Google Sheet file that I created to better understand the problem about MTU fragmentation. And in this case, I need to know what is the payload of the full path. I love IPv6 because in IPv6 this problem is avoided by default, by design. In IPv4 we need to know what is the MTU of the total path, and we can use the ping command HMP echo request echo reply with do not fragment to test all the path without fragmentation. And when we find the total path with the correct MTU, you can change the maximum segment size inside uh, the forward chain of a firewall, for example, in MacroTik. Okay.
So thanks for that. Let me let me be more specific with the scenario.
Mhm.
So say for example you are in an enterprise
Mhm.
and you have let's say two service providers CEs that are deployed in your data center,
Mhm.
and you have a firewall in between,
Mhm.
and ideally you shouldn't run BGP in the firewall ideally,
Mhm.
but you rather want to run the multi-hop BGP where the firewall is the middleman allowing port 179 TCP.
Mhm.
So say for example you allow the source IP and the destination IP with the TCP 179. So my question is, if PMTU is enabled whereby there's a firewall in between, that firewall is blocking ICMP but allowing the TCP 179.
Mhm. Yeah,
Uh,
is different protocol, and the firewall can permit TCP but not permit HMP, for example. But TCP, BGP is not aware about MTU because in TCP, inside the freeway handshake connection of the TCP, there is a parameters maximum segment size that determines what is my maximum segment size and what is your maximum segment size, and we must use the lowest maximum segment size from the two side. And BGP cannot have problem about BGP MTU because they find the correct MTU who's using the lowest of the two. Different is in OSPF, for example, we must use the same MTU on the two interface or the interface involved in the communication, or OSPF cannot run, for example.
So, but if let's say, so I take it that the MTU that you're mentioning, it's ideal for the single hop where the hop is directly connected. But what about a hop that's not what about the peer IP that's not directly connected? Like let's say you're using loopbacks as a source interface.
About
Well,
about BGP or about MTU discovery?
so okay, so what I've seen is, you know when you type in the show IP BGP neighbor, and then you put in the neighbor IP, and then you hit enter, it will give you a lot of information. And in that information, there's a keyword there that's written PMTU. So what I've seen with this, and I'm not testing you or anything. I just need clarity. So what I've seen is there was a firewall in between, and the service provider CE sitting in the DMZ, and then the inside was a Nexus 9K switch. So then the Nexus 9K had a loopback, and the service provider CE also had a loopback. So we ran a multi-hop BGP.
Yeah.
So with that multi-hop BGP, we have noticed that on the Nexus side, the MTU size was 1,500 because we didn't want to spike it to jumbo frames. But now, because from what I know, but please correct me if I'm wrong. Again, I'm looking for clarity. So from what I understand about PMTU is that part MTU discovery, for it to work optimally,
Yes, but you
it
pattern to use ECMP. If something block ECMP, you cannot use pattern to.
no, in this case, we're not using the equal load balancing method. It's active passive.
So, Martin, I think that is a very deep question about Cisco and about the topics that is outside the scope of this meeting. I don't know Cisco 9 switch, and I cannot respond to this question because my knowledge is about MikroTik. I can respond about MikroTik, but I cannot respond about what I don't know.
Okay,
Okay.
no problem, no problem.
Thank you so much for the question.
Martin, maybe if you can share the question, the details on the group WhatsApp, and then we can have a discussion on it, if you don't mind.
Exactly.
Yeah, sure. I can do that. Yes.
Okay, thank you. Let's get the last question. I see Elisa. That should be the last question, and then we can end.
Brother Marco.
Yes, Elisa.
Yes, I wanted just to find about, when I need, what is the best way to announce my route?
We
As
can't
ISP
hear
to
you
announce.
clearly.
Can you hear me now? Can you hear me now?
Some noise in the background, but you can proceed.
And now can you hear me?
Yes, better.
Okay, I wanted to find out what is the best way. The question is to Brother Marco. The best way to announce my BGP to another IS using Necrotic. Yeah.
The best way to announce your network via BGP to another IS is
Yes,
via
yes.
external
To another
BGP.
IS.
Is via external BGP and using output.network using the IP firewall address list if you are using router AS7. Okay, this is the best way. Please don't use connected with other autonomous system. Use a specific list. You must have this network inside your routing table. If you then don't have this routing table, this information inside your routing table, you cannot announce this network to other. Let me explain this topic. If you want to announce from the point of view of router 2, if you want to announce 1 and 2, 168.3.0/24, that you cannot, you don't have this network, but for example, you have one more specific route, 1 and 2.68.3.2, because you receive this from PPPoE, from connected routes, but you want to announce all the network outside your IS, you must have this network inside your route table. And in this case, you can use add destination address 192.168.3.0/24 black hole. Okay, not use the gateway, use the black hole directly. In this case, the black hole route are inserted in your RIB, and if you are in active mode, active static, and if you have this route active, you can send out this network through BGP to another autonomous system. Okay, and when an autonomous system external sends you packets destined to 192.68.3.2, for example, you have a more specific route to reach that destination, and it works. When they send you 3.5, for example, that you have not this route, these route are sent in the bin, okay? And is a protection of your network. If you don't have the route, and if you have the full route, you are sending out this specific packet that you cannot reach directly. Use black hole to create the route and send out to the network, and use more specific route inside your network.
Thank you so much. Thank you.
Last question, Marco. Mike was asking whether, if you check on the chat, Mike was asking a question whether the MT fix the BGP signal VPLS issue in that OS version.
Good question, Mike. I don't have the response to you. I need to see to check the changelog, and in the last time I don't use the VPLS signaled with BGP. I need to check on the changelog. You can check on the changelog. You can try with the lab if this is fixed. I wrote about, I previously read about something about VPN, VPLS signaled through BGP, but I don't have the real response. There is another interesting question. Please share the GNS3 link and details how to install. I insert in the chat my presentation of 2 years ago on the MicroTik Professional Conference with the slide of the presentation. And now I share the link of the video when I speak about how to configure from zero GNS3 to create your lab without using my virtual machine, but with the GNS3 virtual machine from zero. And I explained some topic about the networking inside the hypervisor and how to obtain the result from zero. So
Thanks,
thank
Marco,
you.
for
Thank
the
you
links.
so much.
Thank you so much. Thank you.
I know it has been 3 hours already. We expected it will be a 2-hour session, but yeah, it's already 3 hours. We already past time, but we appreciate the patience from the audience. And thank you so much, Marco, for taking us through the session, taking your time to prepare and delivering such an amazing presentation to us. I believe we've all learned a lot, and we have many people who are using MikroTik, and there are so many questions even on the platform about MikroTik. Maybe next time we can discuss and see how we can address some of those questions. But we really appreciate your time and you sharing the knowledge with us. Thank you so much.
Thank you so much, Martin, to take me into your mentorship program. I love this passion that you transmit to others, and if I need, I can give something back to the community. Sometimes I received, sometimes I want to give something back. I encourage all other people to do the same with friends, with colleagues, each one teach one, and we will see the next meeting.
Thank you so much.
Thank you. Thank you so much.
And thank you so much for Marco.
Bye,
Thank you so much
guys.
for your kind time and your delivering kind lecture. Thank you so much.
Thank you so much, Marco. Thank you, Martin.
Thank you.
Bye-bye.
Bye.
Okay.
Bye.
Bye-bye.
Bye-bye.
Bye-bye. Let's sing.
Ciao.